This is lesson 7.3. In this lesson, we're going to be talking about special products of polynomials. So in this lesson, let's first take a look at what if we had the expression a plus b squared. So let's actually write down here. So a plus b squared. Okay, so I'm going to take that. We're going to use our area method like we've done in the past. So we've got A plus B. We've got one set. And then we have A plus B over here for our second set. So when we multiply these, on that first box, we've got A times A, which is A squared. We have A times B, which is AB. And then we have A times B here, which is AB. And then on our last box, we've got B times B, which is B squared. So if we take that A plus B to the second power, we see that it becomes A squared plus two sets of AB plus B squared. And what you're going to notice over here is that this gives us a square binomial, and this is the pattern that we're going to have. So it's this one binomial, a plus b, raised to the second power. It's going to give us this pattern every time. We're going to have two sets of the same thing in the middle here for that 2ab, and we're going to have the first term squared and the last term squared. If you look down at the bottom one, it's a little bit different when it's a minus b. We still have that first term squared, the last term squared. But in the middle, those two AB terms are both negative, because if I have A times negative B, I get negative AB. If I have A times negative B for the other box, right, then I would have negative AB. So those two together would be negative 2AB, because I have two of them and they're both negative. So that leads us to talking a little bit about a perfect square trinomial. So if you look here, these are examples of what it would look like if it is a perfect square trinomial. So that means we have those three terms. This middle section here is going to be two of those factors. So for example, if you look at this one and you have x plus 5 squared, you've got that x times 5, and you've got two of them. So 2 times 5 was 10, and then you still have your x. So 10x in that middle term. This is what it would look like with numbers versus all variables. So for example, 1a, we're going to take that binomial and we're going to square it. So we've got 3x plus 4 squared. So let's go ahead and write that over here. So example 1, and we'll do letter A first. So we have 3x plus 4 squared. There's our original. So if you think about it as two binomials, so I know I have, if we're thinking about FOIL, right? It's like 3x plus 4 times 3x plus 4. Well, those first terms, we've got our 3x times 3x. So you have 3x squared. Then we have two of the terms where we've got 3x times 4, because remember, according to that pattern that we talked about up here, you've got the a times the b, and there's two sets of them because they're exactly the same in these two binomials. So we've got 3x times 4, which we'll write down here. So 3x times that 4 for our second term. And we know that we have two sets of these. So let's use a third color to show our 2 here. Two sets of those. Plus, we've got our last term, 4, and we're squaring it. So if we want to simplify this, 3x squared, well, 3 times 3 gives us 9x squared. And then 3 times 4 is 12x. 12x times 2 gives us 24x. Plus 4 times 4 is 16. So that would be our simplified version. For letter B, move that over a little bit, we have 5x minus 2y, and we're going to square this again. So these first terms, 5x squared, (5x times 2y), well, we've got 5 times negative 2 here. So 5 times 2 is, let's just write it as our separate pieces. We'll simplify it in just a second. I think it'll be easier for us to see here. So you got your 5x times your 2y. Now, again, we have two sets of them, but both of those terms are negative because of this negative right here, which is what I was pointing out. So we got to make sure that we put our negative sign in there. And then our last term, we have 2y squared. And remember, for that first term and the last term, they end up being positive because this first term is positive by itself anyway. But for the second term, if I take negative 2 times negative 2, I'm going to have a positive number. So just don't forget about that when we're looking at those negative versions. So the middle piece is the only one that's going to be negative because I multiplied them, got a negative number. So for example, like I would have negative 10y or negative 10xy, and then have another negative 10xy. When I add those two negatives, adding it keeps it negative. These outside terms here, they are multiplied. That's why they become positive. All right, so simplifying it up, we've got 5 times 5, which is 25x squared. We have 5x times 2y, which is 10xy. And I have negative 2 groups of that. So negative 10 or negative 2 times 10 is negative 20xy plus 2 to the second power is 4. Y to the second power is y squared. So 25x squared minus 20xy plus 4y squared. All right, so let's take a look at this next really important idea we have here. So it says we're looking at sum and difference patterns. So for example, if I have a plus b times a minus b, notice the terms are the same with the exception of this being positive and this being negative. So when I multiply these two things together, I'm going to get a squared minus b squared. And then this shows it just with numbers and variables versus only just variables. So let's take a look at letter A first, and we'll see kind of what that pattern looks like, and then we'll use that to help us solve B a little bit quicker. So example 2A, slide this over a little bit. So example 2, letter A. We've got t plus 5 times t minus 5. So like we talked about before, we've got those first terms multiplied together. So we have t squared. Then I want to look at these outside terms first, right? Because in the other ones, everything was positive. Or everything was negative, right? We had 2a plus b, or we had 2 of the a minus b. This time we've got 1 of each. So let's look at these outside terms and inside terms separately. So my outside terms, negative 5 times t, gives me negative 5t. My inside terms, 5 times t gives me positive 5t. And then my last terms, 5 times negative 5 is going to give me, we'll just say minus 5 squared. Where's my number? Here it is. Minus 5 squared. There we go. All right, so then we're going to simplify some things. So we've got our t squared. Negative 5t plus 5t, that gives us 0. They're canceling each other out. And then we've got minus 5 to the second power, which is 25. Remember, that negative sign is not inside parentheses. So that means it's minus whatever 5 squared would be. All right, so if I simplify this even just a little bit farther, since that 0 is not making any changes for us, we've got t squared minus 25 for our final there. Every time you have a sum and a difference with the same first and last terms, this pattern is going to happen. Those terms in the middle are going to cancel each other out because one's going to be positive and one's going to be the negative, and they're going to have the same coefficient and the same variable. So they'll cancel each other out, and we're going to end up with this t squared minus 25. So let's take that idea for B and see how we can apply it. Make it a little bit faster. So 3x plus y times 3x minus y. All right, so those first terms, 3x times 3x gives us 3x